So hello, everyone. My name is Zhang. I'm with computer science. My research focuses on the algorithmic foundation of big data analytics. So today I will talk about how to process noisy big data in this setting. So if you look at standard textbooks, you will find that almost all algorithms are analyzed in a model called the RAM model. So where we have one CPU and a memory of infinite size. Okay? So the computation is centralized, and the cost is measured by how many memory cells we read or write from the memory. Okay? But this model is not quite good for big data analytics because so data in massive data may come in an online fashion, and we probably cannot store all data items. Okay? And in another setting, data is collected in multiple sources, and we have to perform a distributed computation. So in these two settings, RAM model does not work well. Okay? So I'm working on called the big data computational models. What we call the big data models. The first is the streaming model. So in this model, data comes in an online fashion, and we can only scan the data from left to right once. Okay? And we have to answer queries at any time step during the scan. Okay? The main constraints here is that we have a very small memory space. We cannot store all the data. And we also want to have very fast updated query time. So it captures a lot of settings, for example, in network routers, in ad auction, telephone switch, a lot of other applications. So the second model I'm working on is called the K-site model. It's basically a distributed model. So where we have K different machines or different size, different parties, each of them holds a piece of data, and they connect to a central coordinator. And the communication, so they want to compute something together by communication. And the goal is to minimize the total bits of communication because that's typically the bottleneck of the computation. We also want to minimize the computation in terms of runs. We also want to minimize the number of runs and the time spent on local computation. And this model captures a lot of practical models and settings. For example, the MapReduce model, the box synchronized parallel model, and settings like sensor network, cloud computation. It's like abstraction of these practical settings. So there are a lot of challenges to design and analyze algorithms in this kind of big data models. So one of them is because real-world data is very noisy. Okay? So for example, different videos in YouTube may look different, but they actually are the same contents. They look different because maybe you have one is like after data compression and resize, reformat, this kind of thing. And if you want to search, for example, the homepage of Indiana University, we probably will type IUB, Indiana University, Bloomington, or Hoosier University. They'll give actually the same results. I mean, they are of the same meaning. So to perform this kind of noisy data, a typical way is to perform comprehensive data cleaning, or they call data duplication. The problem is we cannot do this in these big data models because we have very small space and we can only use a very small bits of communication. So we cannot do this kind of very expensive, resource expensive duplication. So with my PhD students, we are working on how to design this distributed streaming algorithms that can run on the noisy data directly and resolve the noise on the fly, and then to still be communication space efficient. And this project is funded by NSF. I think that's all I want to say. Thank you.